So, good morning, CIMAGE. I am Aditya Mangalam and I am here to give a PPT about multiple integration. So, first of all, I will start with the basic one. So, we have all know that what is single integration. So, a single integral is a mathematical operation that calculates the area under a curve. And that is the main point is that function of one or single variable we deal with in single integral. So, single integral is also known as the inverse process of differentiation. When the given function is differentiated again, then the original function we will get the original function. So this is what we know about the single integration. We done this, and this is the sum of the mathematical rule that this is same as this. We summation, we divide a function into how many parts, infinite parts we can divide it into, and sum all the small parts and make them integrate. And this is the example I have taken. So main difference in single and multiple integration is that it is done in 2D figure only. So as we know that if we find the area of this curve, we find this much area, and not about what is behind that area. Now, I am starting my topic. I have given a topic about the multiple integration. So let's start it. So I am starting with the definition. So multiple integration is a method of calculating the area or volume of a region of a function given function by integrating it. And this is the catch that more than once with respect to different variables. There are more than one variables in multiple integration. So I am talking about the history here. So one of the pioneers of multiple integration was Johannes Kepler, who first used the successive approximation to calculate the volume of a wine barrel by dividing it into many parts. In 1615, after many years, another important contributor of multiple integration was James Gregory, who introduced the idea of integration along a curve. That what we have seen, what we have used today to find the area of a curve. That was given in 1668, a long ago. So many mathematicians such as Leonardo Euler, Joseph Louis Lagrange, Euler's theorem, he gives Euler's theorem, he gives Lagrange's mean theorem, he gives Laplace theorem, Augustian Louis Cauchy gives its theorem, Carl Friedrich Gauss, the Gaussian law, Bernard Riemann-Riemann integration, and Henry Leslie, I don't know about them. So are also some of the important names in the development of multiple integration. So therefore we can say that the multiple integration is not invented by a single person. This is a achievement and hard work of many great mathematicians. So now this is double integration. There are two variables as you are seeing, x and y. Again we have two summations, first in x-axis and the second in y-axis, and we can divide. I have divided, this picture is not that much clear. So I have divided x-axis into some countable parts and y-axis into some countable parts, and sum it to find the area. So this the main difference, as you have seen that if this is a in single integration, we find the area of this paper only. I am not talking about the width of the paper or size of the paper. We find this much area only. But in double integration, we assume the two variables. First is x variable and second is the y variable to find the area. And this is the for more clarification, I have projected this in y-axis, so you can understand it better. So now this is triple integration, another form of multiple integration. So in this I have divided. You can see that I have. Please go to previous one. This is the same curve. I have example in the next slide. Previous slide gives the area, but this slide gives the volume. I have taken three axes: z-axis, x-axis, and y-axis. So there are, as you can see, there are three variables, x, y, and z axis, and three and we have some three summations here, and divided into many infinite times. First, x-axis can be divided into n parts, then m parts, then p parts, respectively. Now we have read this, the surface area, how to find the surface area. This is what we are understanding in the class. So double integration of two variables can be written as if the figure is in y-axis, then limit from a to b. The a to b are limit of y-axis, and a, y, and by are the limit of x-axis. Some opposite direction in this. And the volume is three variables x, y, and z. So there are two variables x and y. We have to integrate the function to find the volume of the curve. So I have taken one example for better understanding. So I have taken the hard one. So a difficult one. So it is given that 0 to 1 and 2 to 3 x square plus 4y in two variables dy and dx. So first of all, we have concentrate on this part. So we write as usual 2 to 3, and here x we have to integrate in the form of dy. So the variable x acts as a constant here. So x square into dy plus 4y into dy from 0 to 1 and 0 to 1 and dx. So 2 to 3 x square y plus 2y square 0 to 1 dx. 2 to 3 it gives us x square plus 2 into dx. So we have calculated the area in the y-axis. Now we have come into y-axis. Yes. We have calculated the area in y-axis. So this axis, our area is completed. Now we are going to find the area of this part in the x-axis part. So for finding the area, it can be written as x cube upon 3 plus 2x and limit from 2 to 3, which gives us the result 27 by 3 plus 6 minus 8 by 3 minus 4. So 19 by 3 minus 2. So 13 by 3 is square units are the required area of this function. So now you can, I hope you all understand it, and you can calculate the area of this curve. So here is some mathematical memes I have created here. So single integration is liked by all. Double integration may be difficult for someone, but triple integration is much harder. So that are the cases.